Alright, so in this week's class we were looking at curtain wall systems. And there's a couple ways to make them. One way we've looked at in the past is on a mass, using that mass to create a curtain wall system. But the way I typically do it is by using just a wall. And when I click walls, as we looked at in the last tutorial, I have a series of basic walls here. If I come down a little lower, I have a series of curtain walls. And then I have a stacked wall. So let's just jump in with the basic curtain wall 1. And if I draw a wall here and just plan, I'll make it 50 feet. That's it. You can see that there's nothing really to it. I'm going to jump up to my 3D view here, and I'm going to go to shaded mode so we can just see that kind of glass. Right now the curtain wall has no curtain wall grids or mullions associated with it. And if we wanted to, we could come over under architecture and put in a curtain grid. These will run by default, all the way horizontally when we're on a vertical line, or vertically when we're on the horizontal line. And you can see that I can just click where I want my curtain grids, and I can also change and say that I want one specific segment of grid. Let's say that right here I want to divide that wall up, and maybe over here I want to divide it there. I can also do all except picked, so if I put a horizontal in, I can turn off where I don't want it and hit enter, and I get grids in other spots. Once I've done that, I can come back and apply mullions to these grids. So if I click the mullion button, right now I can do a single grid line, a segment of a grid line, or all grid lines. So let's use all grid lines and apply mullions to this class. So these are just default simple mullions. There's nothing too special about them. If I look in level 1, let's look. That's the mullion. It's the portion of aluminum, or it's usually aluminum, sometimes reinforced with steel, that holds the glass in place. A little bit later we're going to be looking at how to change that, and the opportunity to use existing mullions from manufacturers by downloading them from seek.autodesk.com or another website on the internet. I'm going to jump back in my 3D view, and I'm going to undo the mullions and my curtain grids. So here I'm back to just the basic wall. And just like before, in any other wall, I can come in and edit this and say that I want it to be taller or shorter. I can control that numerically and say it's 12 feet tall. If I want, I can come into the wall here and edit the profile. So if I wanted to draw some kind of funky shape for my curtain wall, I could. I'm going to have to split this line here. I'm going to split the circle too, there and there. And using trim, I'll come in and trim this portion and delete that. So if for some reason I needed a curtain wall to look this way, it's something I could do. And again, I could come in, architecture, mullions, all grid lines, and I could apply a mullion around that curtain system. Undo all that again, get back to just the basic wall. While you can control mullion placement through your own custom curtain grids, for the most part I use parameters of the wall. So here if I click edit type, I'm going to immediately duplicate this and just say this is test wall 1. And now under my test wall 1 I have a series of options here, and the ones I'm concerned with are the vertical and horizontal grid. Under the vertical grid, I can say, well, I want a fixed number of mullions, and right now they'll be spaced at 5 feet, and I'll say OK. And under my wall options, I can say, oh, give me 11 mullions. Apply that, and I can see that they're evenly distributed across the curtain wall system. They're at 4'2". If I came back in and changed that to say just 5, they would all evenly distribute again. There are other options you can do. Instead of saying a fixed number of mullions, you could say a fixed distance and say that each mullion needs to be 6 feet apart. You can see what happens there is that it starts on one end, and every 6 feet it puts a mullion until we reach this spot, and then it's just the remainder. Sometimes this is fine. Other times you want to have that leftover space centered in between. So what I typically do in the office is not use a fixed distance, but use a maximum spacing. and say that the mullions can be no more than, say, 5 feet apart. And you can see what happens there is that they evenly distribute again. These are, I just so happen, because it's a 50-foot, well, let's do that. Because it's a 50-foot curtain wall segment, let's drop it down to something unusual, 42 feet. Now, if this worked correctly, we're again evenly distributed, knowing that no mullion would be greater than 5 feet apart. I can also control here under the horizontal layout and say that my maximum spacing maybe is 12 feet. Say OK. So as I drag this curtain wall up, it will add horizontal mullions so that the spacing is never more than 12 feet. Here in, so I was actually in plan, so I couldn't get that. Let's see. Have to be an elevation to mention that, but I know that that's the case. Let's jump back here. With the wall selected one last time, we're going to look at the curtain wall, and we have a series of mullions that we can apply to this system. So here we have the interior type, and that would be a mullion that would line up within the system. You can see that this is the jamb, and while this mullion would be required to hold two pieces of glass, the far right, the far top, bottom, and far left only require holding glass on one side. So the interior type is important that we always have, say, 2.5 by 5 rectangular mullion. We'll do the same thing here. You can see that this is a default profile that's been loaded for the mullion, so it's nothing too intricate. But if I came and said that I want, let's look here, well, these are all going to be the same. I can apply the same mullion type all the way around. So these are all the default mullion, 2.5 inches by 5 inches on all sides. If I wanted to get more detail than this generic profile, the best place I think to go is probably just seek.autodesk.com. And once you're on Autodesk's website, you can search through tons of BIM information. And I've looked up here a Conair 1600 6-inch SSG curtain wall system. What that means is that it's structurally silicone glazed, and here you can see that the outside has a mullion cap. That wouldn't necessarily need be something that would be needed. So I can download the file here, and I'm going to open it up. I have to upgrade because I'm currently in Revit 2016, and this mullion system was made in 2012. This is just a model. This isn't a special family or anything, but it's a model that contains different versions of that Conair system. There are other brands besides Conair. Depending on where you're living and working or where your project's based, you'd want to find a manufacturer that is common. So after a few seconds here, we're going to have the Conair model opened, and I'll be able to copy and paste their mullion system into the new project here and use those mullions for this curtain wall. All right, so after a few minutes, it's actually upgraded, and you can see that there's a series of different curtain wall systems here. Let's take a look at this one. This is a 1620, 6-inch with 1/4 inch infill. We came over here. This is 1-inch infill, so this is double glazed, and this is single glazed. I'm going to jump into level 1 and take a look at the mullion. You can zoom in and see that there is a great deal more information. Let's see if I'm trying to figure out if this is drafted or is actually modeled. It looks like this is completely modeled. So I'm going to close out of this, and if I just take this segment, I'm going to copy that, and I'm going to go back to my project and paste that segment of curtain wall in. So with pasting the Conair system in place, I'm able to now change my properties of my curtain wall to use those mullion types. So here, I'm going to change my interior types to the Conair interior. Conair interior. On my horizontals, I know that I have the Conair sill and the Conair head. And then we have the left and right hand jambs. So there's the left and the right. Apply. So you can see that the model changes slightly. If we look at it in plan, not a whole lot has changed. The position of the glass is different than where we had previously had it, but Conier's system doesn't have a lot of information in this profile. If I jump back to, let's see, the family, this Connier family, was actually the file that I had opened. So let's open up that component again. All right, so we're back on the Connier file, and you can see that there's specific details called out. So if I just open this detail, this is just a drafted region. It's just a detailed component, and I could copy that and use that in my detail drawings, but I would never want this amount of information in just my floor plan at 1/8 inch. So let's just jump back to our model. We've applied these mullions to the system, but when we look at it, there's not a whole lot of detail that we can see here. But that's just one way of getting, we can actually then delete this, getting existing in real life mullions modeled in a project. The next thing I want to look at is just a couple options on how to place those mullions. I can see down here that if I wanted to, I could slant them at, say, 15 degrees. We could have kind of a strange mullion layout that way. I wonder, I've never actually done a horizontal grid. There you go. You can actually keep these things perpendicular by making our horizontal bent too. Just an option. The next thing I want to look at is what goes in the mullions. And right now we have a glazed panel. If I come up here, I can change that so that it can be a solid panel. But I want to take it a step further, and I want to custom design my own panel. And to do that, I'm going to have to make a new Curtainwall family, Curtainwall panel family, by going File, New, Family, and then selecting Curtainwall panel. I'm not doing a pattern-based panel, I'm just doing a normal panel. So this is the first time that we've looked at what a family is. And a family is a adaptable and parametrically driven component for Revit. So you can see here there's actually nothing in the file other than some reference line work. And what we have is a reference plane that's called left. We have one that's called right. If I hover over this one, it says it's called center, and this one's called the front. Right now we're just looking at our reference planes in plan, but we also have elevations. So if we looked in the left, we have an upper plane called top, and a lower plane that I believe is called, let's see, it doesn't have a name. It's just the reference plane at that reference level. So let's jump back to plan. Let's imagine that we want to have a panel that sticks out, and we want to be able to control the depth of how far it sticks out and create a series of different panels that maybe are a 6-inch pop out, 8-inch, 12-inch, 400-inch, it wouldn't really matter. We're going to start off initially by doing just a simple extrusion, and then we're going to change and do a panel that tapers. So the first thing I'm going to do is go to Create and create a new reference plane. This reference plane is going to represent the front of our panel. So here, knowing that I'm starting off of this line, which is called front, this is going to be our plane for depth. So I'm going to name it Depth Plane. Say OK. So when I have it selected here, I can set that depth plane. I can move it around if I wanted. I can come in and say I want 4 inches. The next thing I want to do is to create a profile to extrude as the panel. So I'm going to go to Create, and I'm going to make a simple extrusion. I'm going to just draw right now quickly what that extrusion will look like. There's 3 sides of it. It's not snapped to anything. I'm not really being too precise. I'm just making sure that it's orthogonal. And I'm going to say that my panel is a 1/2 inch thick. So I'll type using offset. I'm going to say I want to offset 1/2 inch. If I hover over my lines here, I can hit Tab and offset all of them 1/2 inch. And then I will come in and just close off the sides there. And lastly, I'm going to snap the outside to our reference lines so that if I ever move a reference line, our panel extrusion profile will move too. So using AL, I'll align to the left reference plane, my left line, and lock it. My front to, well, this is the depth plane, gets the front, lock that. On the right, I'm going to lock my right side. And then you can see that I need to set a dimension from here to here. And once I click this line, I can say make that 0.5 inches. And when I come out, I can click on my dimension and lock that dimension. What that means is if this line ever moves, this line will always be 1/2 inch from that line. So I have to do that a couple more times on the front. Set this one to 1/2 inch. Lock my dimension, and one last time over here. This line is 1/2 inch. Leave that, click my dimension, and down here, lock that. Once I have these, I'm going to say that if I just leave it simply, not selected the lines, you can see that my extrusion ends 1 foot above, and it starts at 0. And that's fine for now, so I'll say finish. And if I go over and look at my left elevation, there's my extrusion. I'm going to say AL and align the top. This is my top reference plane to the top of my system and lock that. So now what I have is a system that if I change this height to say 10 feet, my infill panel extends. If I come back to plan and change this and say, okay, you need to be 3 feet on each side, it extends in both ways. Right now we're telling the system that from the center line there are always equal dimensions left and right. So if I move this, I'll always have a symmetrical panel around this center line. The last and final part that I need to do here is to set this depth. Right now if I change it to 6 inches, the panel will update. But I want to be able to control this in the future, so I'm going to say DI to create a dimension, give myself a dimension here. Then by hitting escape and not having anything selected, I'll come back, select my 6-inch dimension, and here under label, I'll tell it that this is going to be a specific parameter of the panel. So I'll add a parameter here. We'll call this depth. There's a series of different tools down here. Right now we're just going to be supplying a dimension for it, and we'll say OK. If I come to this icon here, which is my family type, I can create up 3 different or endlessly different numbers of this family. So let's create a new family type, and we'll call this depth panel A. And under depth panel A, we're going to leave it with the 6-inch that we already see right here, so 6 inches. We'll create a new one and call it depth panel B. And this time let's make this 14 inches. If I move this over, we should be able to see that. Now we have a deep panel. Let's make one more new. This is depth panel C, and maybe this one's only 2 inches, so we get lots of difference there. I'm going to go File, Save as a family, and just on my desktop I'll say Panel A. And I'll load that into my project. So now I'm going to go to my 3D view of my curtain wall here, and if I click one of the infills and hit Tab sometimes helps, I could change this from the system panel to my panel A system, and I have panel A, B, AC. So let's make it B. Cannot make panel. I think with the irregular geometry we have here, it's not going to work. So let's get that out of the way by putting these back to 0. Okay. Let's see if I can grab this one now. There we go. It just didn't like not having 4 sides. So I can make this one B and make this one C. So this is one way that I can control what the infill of this curtain wall is. You can see that I clearly have a problem. There's a gap at the top and the bottom. I wouldn't want something that was doing that. So I would actually use an opportunity to cap this panel off and build a little mass that would always snap to the top. Let's look at something that's a little bit more complicated and that would allow us to slope these panels back and forth. So I'm going to go back here, and I'm actually going to delete the panel extrusion that we had. Right now I have this dimension under each one, panel A, B, and C. Our depth is set to 6 inches, 14 inches, and 2 inches. I'm going to want to add a second depth so that we can get sloped panels. So if I say I'm going to create a new reference plane, and this reference plane we'll call depth 2. Depth plane 2. There, let's call it that. I can create a new dimension for that. I can set it up to be its own new parameter, and we'll call this one depth 2, and say OK. So now, instead of creating a simple extrusion, I'm going to create a blend. So the first blend is going to be on the reference level, which is, if we look here in elevation, it's our first blend profile is going to sit on this plane, and our next blend profile is going to sit on this top plane, and then they'll blend together. So first I'll just go back to my reference plane. I'll say create blend. I'm going to do just as I had done before. Draw these lines here. I'm going to align them to these planes and lock them. This is my depth 1, lock that one, left here, AL, lock that one. I'm going to offset this again 1/2 inch all the way around, and I'm going to close this panel off. And coming in, I'm going to have to dimension this one last time. I'm going to do it all at once. These are already all 1/2 inch. So escape, click this dimension and lock it. Click this dimension and lock that. Click this dimension and lock that. So that was my first profile. This is right now on the base. But if I want to edit the top profile, this is the portion that we will blend to. I have to click Edit Top. And here, I want to make sure that I'm drawing this profile at the top plane. So to do that, I have to set my work plane, and I'm going to say, okay, be at the top. And now when I draw something, I'm not drawing here on the ground, I'm actually drawing up higher. But it's still in plan so we can see it. So same deal here. I'm going to come around and draw these sides. You can actually draw a little 1/2 inch piece there and a 1/2 inch piece there, and I'll offset this top one 1/2 inch. Turn that one up, turn this one up, and I'm going to trim these here and there. And once again, aligning to the outside and locking to my depth 2, locking that to my right side, locking that. And once again, just get my 1/2 inch dimension so that it's always a 1/2 inch deep panel. This one, lock that, and lock that. So what we have now is you can see the gray profile below and the pink profile above, and they'll blend together. Let's try it out. Here in 3D view would be the best way to see it. I'm going to say go to shaded, and let's change under our family properties. We have 2 different depths. So the first one, let's make this one 10 inches and blend down to just a 2 inch depth. And this is depth panel C. You can see that one there. If I go to depth panel B, well, maybe this one's 4 inches blending to 14 inches. Apply that. And for depth panel A, let's just do a 6 inch to maybe, there we go, 1/2 inch. It needs to be a little bit more than 1/2 inch because my depth is a 1/2 inch. We'll make it 3/4 inch. We'll say OK, load this back into our project, and we're going to replace and overwrite the panels we already have. So do that. I'll jump to my 3D view. I'm not going to save this project. You can see we have a little bit of a glitch because the top plane is higher than the height of our system. That's not a big deal. Let's jump back to our left. Oh, the blend. I'm just going to try to align the top there. Blend is too thin. It's not good. Align to the top and lock that. Let's see if we change our type, if that remains true. That one's good. It just wasn't locked to the top reference plane, so it was always maintaining an arbitrary height. We'll say OK. Load this back into our project 1. Override and replace. And now if we look at our 3D view, we should have sloping panels. So this is just an introduction on curtain wall families and how we can go about creating custom infill panels. Really, we can create custom mullions, we can change our spacing and orientation of those mullions, and as we move into more detailed aspects of drawing, the wall sections and sill, jamb, and head details, we'll look specifically at how to draw kind of detailed components on the nitty-gritty details. But that's just the overview. If you have any questions, you can leave comments below.